Hello, this is the generally approachable Sudoku for the 26th of March 2024. It is the Czech outsider Sudoku, I think. If that's how you pronounce it, yeah, the Czech outsider Sudoku by Bill Murphy, featuring a very interesting rule set. So let's take a look at the rules. Normal Sudoku rules apply. So place the digits 1 to 9 every row, every column, and every 3x3 box. Clues outside the grid indicate digits that must appear along the indicated diagonal. So taking this very bizarre looking clue over here, that implies, or well, that states that this line over here must include the digits 7, 7, and 7. So yeah, this must contain the digits, this diagonal must contain the digits 3, 3, and 3. And I assume that having like 4 3s, something like this, is also okay, because this is the minimum that you need. You need at least what is shown here. And I assume those are all the rules. So with that, let's just begin solving. A very interesting name for this puzzle, but I think we start with the corners first. For example, those digits must just be 7 and 8 because the the diagonal indicates so. Not 7 and 8 here, 3 and 4 over here. Now for the diagonals on the outside, we can actually do, well, we do know that that set of digits clashes with this digit over here. So 1 must be in this diagonal somewhere, but can't be in those cells. So 1 must be in one of those cells? I guess so, but that's not very useful. I don't know. I guess this has to have 5 and 6 in it. This has to have 1 and 2 in it. Okay, I see. This 4, 7 does tell us something. 7 can't be in those cells, but 4 can't be in those cells either, because there is already a 4 in the box. So those outside cells must be 4 and 7, and we can actually resolve that with the 4 over here. Interesting. That resolves the 3, 4 here. We can probably do that all around the board. For example, yes, the 1, 6 here cannot be in those cells, so it must be outside. And this 6 here resolves that. So 1, 6, this 6 resolves to 5, 6. For this 3, 8 here, 3 and 8 must be on the outside. 8 resolves that. 3, 8, which resolves to 7, 8 up here. 2, 5, 2 5s must be on the outside. This 2 here resolves that, which resolves this. So there you go. Very interesting rule set. Okay, what else can we do? Well, I guess the repeated digits are pretty interesting, because for example, this repeated digit with 2 8s occupying 2 whole boxes means that each box must have one of the 8s, right? So there's 1 8 in each of these boxes. This 8 actually tells us where the first 8 is. The second one I don't think we know yet. But okay, we can probably repeat that as well. 6s. This 6 tells us where the first 6 is. Oh, and that tells us where the 8 is. Alright, very cool. So for the 4s here, 4 is in one of those cells, and this 4 tells us where it is. It must be here, which indicates that the 6 in this diagonal can only be there. The last one will be 2, and firstly, yeah, 2 must be here in this box, and in this box has to be here as well because of this 2. Okay, we have a lot of pairs to work with now. So this is 5, 6, I think, and that is resolvable. Those digits are 7 and 8. Yep, and we can resolve that. What else do we have? Oh, do we not have this? I thought... Okay, weird. Those digits would be 3, 4... Oh, 3 and 4. Hey, yeah, I don't know what I'm saying. Yes, only 3 and 4. Alright, and finally a triple here consisting of 1, 2, and 4. Right. This cell can't be 2 or 4, so it's a 1. 2 can't be here, so it's a 4. 2 goes here. That is just a free digit, which would have to be like a 9, I guess. Yep, those digits have to be 1 and 7, which we can't resolve. Those digits are also, I think, 3 and 5, but we can't resolve that either. Cool. Oh, a lot more pairs. Wow. Okay, we just have pairs everywhere now. It's like a pair exercise thing. This is 5, 7 as well. We can't resolve that. Those digits are, I think, 1 and 3, which you also cannot resolve. Interestingly, each of the 4 edges, each of the 4 things pointing out here are 4 different ways of combining the two of the 4 digits. 2 of the 4 odd digits excluding 9. Alright, let's keep going. This is 2, 3, I think. That digit can't be 2, so that's 3. Wait a minute. I made a mistake. Oh no, I'm so stupid. This can't be 3, so it's a 2. What am I doing? I thought I made a mistake solving the puzzle. I did not. This has to be 1 and 8. 1 goes here, 8 goes up there. This has to be 4 and 5. This can't be 4, so 5 goes here, 4 goes here. Those are 6 and 7. This must be 6, that must be 7. We're almost done. I think we have to try and use the remaining 2 clues here. So, for example, this diagonal must have 3 7s in it. This outcome be 7. So the only places you can put 3 7s are here, here, and there. So they are all just 7s. As for 3, well, 3 can't be here. So the only places you can put 3 are here, here, and here. So those are all 3s. We can probably resolve a lot after this. This has to be a 1. That has to be a 5. Yes, and a bunch of triples to end off. This has to be 2, 8, 9. 8 has to be here. This 2 resolves the remaining 8, 9, 2, 9 pair, sorry. 3 also resolves this 3, 5, and I would assume 7 here resolves this 1, 7. Very nice. More pairs. This has to be 2 and 9. Yep, we can tell because of the 2 here. And those just have to be 4 and 5. 4 is resolvable. I think we're almost done. That digit is simply a 6, I think. So that gives us, I think, 9 and 4 here. Yep. And a bit more to go. This has to be 1 and 6. We can resolve that. And the last digits are 8 and 9. And this 9 resolves that. There you go. Solve the puzzle in 5 minutes and 44 seconds. Well, this was certainly a unique experience. I don't know why this thing is... I still don't know why it's called the Czech outsider Sudoku. I do know that outside Sudoku is a different thing though. And we have seen that very recently on Guess. So maybe that's like a sequel kind of thing. Whereas like we had regular outsider Sudoku, so now let's do it diagonally. Yeah, so yeah, I hope you enjoyed this video. I'll see you guys next time. Bye bye.